Welcome to another episode of GenServer. GenServer is an Elixir tool that is used to create stateful process, and this process are known to be long running. And also they have their own state which is kept in the memory until that process exits. So in today's episode, we shall get started in creating stateful process that you can interact with using the GenServer. So before we get started, please ensure you have an Elixir project, or if you don't have one, you can start one by running the mix new, pass your project name, then don't forget to add the -- soup flag. So this will ensure that your application has a supervisor. So once that is done, you can create the server file. So under the lib, go ahead and create your server file in there. The file created is where we are going to define our server module, and this server module is the one that we're going to use to start the GenServer process. So the server module will be responsible for sending messages to the given phone numbers. And in a scenario where these messages fails to reach out to those phone numbers, so we shall retry sending them, and this retry will be limited by the maximum number of retries we pass to our server module. Okay, so let's get started. So to define a module, use the def module keyword. It's an inbuilt keyword in Elixir. Then we need to end that. So in here, define your module, your server name. So I will call it the message server. Then since we want to use the GenServer, let's pass the use gens. Since it's a GenServer process we're going to start, let's pass the use GenServer. So the use GenServer will automatically inject the at behavior GenServer. We are using a GenServer behavior, and to explain behavior in Elixir can be related to contracts in a real world. So in a contract, you usually define some policies or agreement that needs to be followed. A scenario where these policies or agreement is not followed, it means that one of the party can terminate anytime because the contract was not followed to the letter. So similarly in Elixir, behaviors plays two major important role, and in a behavior module, there are some set of functions which are implemented, and also it checks whether this set of functions are actually implemented. So this behavior is usually important when using a public API across different modules, and GenServer is one of example of a behavior we have in Elixir. So that said, it means that whenever you pass the at behavior line to your module, you must implement those set of functions defined in that module, otherwise an error will be raised. So the GenServer module has a set of callbacks functions which are implemented by default, and these functions are required by the GenServer behavior. This is the GenServer hex doc. So in here you can see there are some set of callback functions which are defined. So you can decide to override this callback function, but you need also to be aware of two things when overriding those callback function. So first is the argument. Be sure of the argument that callback function takes, and also be sure of the return value supported by that callback function. So now that we have our server module defined, let's verify that our code is actually compiling. To do that, you need to open your interactive shell. So to open the interactive shell, use the command ix-s mix. So that will open the interactive shell. So our code is compiling, but we have a warning displayed to us. So this warning is about the init callback function, which is required by the behavior GenServer. And we haven't yet defined that in our server module. So since we have not yet defined it, it will be injected by default in the message server module. And the default implementation looks like this. So since we want to have our init callback, we can easily fix this warning by passing the init callback in the message server. So let's define our init callback. So you can see that it takes in an argument, the init argument, and it returns an atom. Okay, let's just pass it the way it is. So the init argument. So we are passing the init argument here. So before defining the callback, remember I mentioned that we need to be aware of the argument that we are passing through that callback function that we are overriding, and also the return value that we are returning. So let's go back to the GenServer head and get to have a look at the init callback. So it takes one argument, and that's how we have defined it. And also it has different return types. So you can decide to return a tuple of an atom, okay, and a state, or the other. So in our case, we're going to return the first one, which is the tuple of an atom, okay, and a state. So if we go back to what we have defined here, so the first thing is we need to know what do we want to keep in the state and why are we keeping them. So our message server will be responsible for sending messages. So we need to know which message will be sent successfully to the given numbers. So to know that, we need to keep track of the list of phone numbers whose message has been sent. And also for those that fails to be sent, we need to retry them. But this number of retries needs to be determined by the number of maximum retries we pass it to the state. So once the number of retries is exhausted, that means we stop retrying sending the messages. So with that logic, we need to have our state defined. So this is the initial state. Let's pass it as a map. You can decide you can pass it with any data structure you wish to, but normally I would advise that pass it with a data structure that is easily to access. We need to keep track of the max retries. And by default, I will set it to maybe 5. It's not a bad number. And also we need to keep track list of numbers that were sent successfully. So that means in our server module, we should be able to track the phone numbers whose message was sent successfully, and also know the number of maximum retries that were done for those that failed. So we need to update this. So our initial state will not be the initial argument, but now we pass it the state that we have defined. Okay, so since we're not using the initial argument, let's put an underscore to it. And we can go ahead and recompile this. So we have fixed that warning. So in order to initialize our process, we need to start our GenServer process, and that can be done by calling the GenServer.start function, which is going to start the GenServer process without linking it to the current process. Or also we can use the GenServer.start link function, which starts the GenServer process but links it to the current process. So let's use the GenServer start for now to start our GenServer process. Whenever you start your GenServer, by calling the GenServer start, it is going to invoke the init function. And once the init callback function is invoked, that means our process will be initialized. And since we are returning a tuple of an atom, okay, and the state, our process will be initialized successfully in this case. We shall be expecting the GenServer start to return an atom, a tuple of an atom, okay, and a PID. So I'm going to pattern match that. And let's call the GenServer start function. So to start the GenServer process, the first argument is the server module. Then also check the second argument, which I will pass it an empty list for now because we are not using the initial argument. So about the second argument, when starting a GenServer, you can optionally provide a list of arguments which will be available in the init callback function. So since we are not using the initial argument, let's pass the argument as an empty list, and this argument will be available in the init. So to do that, first before running that, we need to verify that is the case by, we can always print the argument that we are receiving in here. So let's print that argument. And then we can inspect the argument we are passing. So our argument here will be, let's pass the init. So I'm inspecting it. Okay, so that will mean we have to recompile this. So I'll just recompile first. Then let's call the GenServer start function. So define GenServer, remember we need to pass our message server module. Then pass the list of arguments. So in our case, I'm passing an empty list. And from the output, you could see the argument we passed. And also the return value is an tuple of an atom, okay, and a PID. So this proves that our GenServer process has been initialized and created successfully. So we can also play around with the argument. So let's say we wanted to use the argument. So in our argument, we can make the max retrace be flexible. So that means it's find our max retrace instead of setting it in here. So to do that, we can, so since we are passing a keyword list, so let's access that max retrace by calling keyword dot get function. So the initial argument is a keyword list. Then we can retrieve the max retrace from it, and by default it will default to 5 if the max retrace is not passed. So let's also inspect our state just to be sure what we are having. So I'm going to copy paste this and refactor by passing state. So this is the initial state. And also here we're going to inspect the state. Okay, so now we want to start our GenServer process, but now we are not going to pass an empty list of argument, but we're going to pass a keyword list that will contain the max retries. So remember, GenServer is a long running process, and our server module is now running in the background. So to do that, let's see if we can start a GenServer without stopping the current process that is running. We need to recompile this first. So it's just good to play around with this. Let's just start and see what we'll get. So we're being told the initial argument is an empty list. Yes, we did not pass anything. So let's pass the max retries and give it a different number from 5, so maybe 3. Yeah, so we can see the print message. So the max retries is 3 and the initial state is here. We have the max retries as 3 and the phone numbers as an empty list. So something else to notice is, let's say the first time we start a GenServer process, we have this speed, which is speed 0.225.0. The second time we have the PID 0.240.0, and now we have the PID 0.241.0. So does this mean that we have started different GenServer process with the same server module? Because each time we start a GenServer process, we are starting another different process with a different PID. So let's see if all the processes are alive. Because we have override the PID, so the last PID will be for the last process. So let's check the last PID. So that's alive. Let's then check the second last one. So that is the 0.240. So the PID here is the kernel function PID that I'm using to define our PID, the PID that we have overridden. So it's alive. Let's check the one for 225. So all the 3 processes are alive. So you can decide if you wish to stop the GenServer from running. If you wish to stop the server from running, you can use the GenServer.stop and pass it the PID. So let's do that. So call the stop function. Then pass it the PID. So I want it to stop the first one. So stop the first one. So let's see if it's alive. It's not alive. Let's see if the other ones are alive, just to be sure that the other ones are alive as well. Yeah, so we have managed to stop the first server from running by using the GenServer.stop function. So that's it for this episode. So in this episode, you have learned how we can start our GenServer process by first defining the server module and initializing the process. And also you have seen that we have been able to start different GenServer process using the same server module.